Hello, 6th grade. In this video, we are going to go over one-step equation solving with addition and subtraction. We're going to look at what we reviewed from class from Khan Academy, and we have this balance, and we have Mr. Pink, and we want to get Mr. Pink alone on one side in order to find out Mr. Pink's weight. So to get Mr. Pink alone, we have to get rid of, the two blocks that is with Mr. Pink. If you notice now, we're not dealing with an equation. We want to be balanced on both sides. So therefore, we have to also, from the right side of the balance, take away 2 from the right side in order to balance out the scale. Mr. Pink now equals 7. If we look down at the algebra part of this, we start off with x plus 2 equals 9. Then what we did to the balance is we subtracted 2 from the side that Mr. Pink was on, and to balance that back out, we had to subtract 2 from the right side of the equation. So the value of x, or the value of Mr. Pink, was 7. Let's take a look at another example. In this scale, we have purple pie, and we want to get purple pie alone. On the left-hand balance, we have purple pie plus 1 block equals the 4 blocks on the other side. So in order to get purple pie by himself, we want to take away that 1 block. When we take away that 1 block, we are no longer balanced. So we must go to the right side of the balance and also take away 1 block. Once we have done that, purple pie is now balanced with the 3 blocks on the right-hand side. So the value of purple pie is 3. Again, if we look down at the algebra, we have x plus 1 is equal to 4. And we want to find the value of x. So therefore, we took the 1 away from one side. Then it became unbalanced. So we had to take the 1 away from the other side to get the value of x. Now let's take a look at an equation without the balance. Let's say we have y plus 8 equals 15. My first goal is to isolate the variable. That means I want to get the variable by itself on one side of the equation. In this case, that variable is y. In order to get y by itself, I need to get rid of the plus 8. I need to do what's called the inverse operation. The inverse operation of addition is subtraction. So what I'm going to do now is I'm going to subtract 8 from this side of the equation. Now think about that balance. When I took away those blocks, now I'm unbalanced again. So in order to balance out my equation, I must take away 8 from the right side of my equation. What I'm left with on the left side of the equation is y plus 0. Anything plus 0 is going to be that number. So therefore, we can just put y. And then on the right side of my equation, I'm going to do 15 minus 8, which is 7. So the value of y in this case is 7. I know you could have seen that right away by just looking at the equation. But remember, our purpose here is to prove the math behind this. If I want to see that my answer is true, that y does indeed equal 7, I can do a substitution check. I'm going to substitute the value that I found for y back into the equation. So if y plus 8 equals 15, I'm now taking my value of 7, substituting it back in to now see if both expressions on each side of the equal sign are equal. 7 plus 8 is 15, and yes, that does equal the right side of the equation, and I'm perfectly balanced and very happy. Let's take a look at one more example. 120 equals x plus 40. I want to again isolate my variable, and this time the variable is on the right side of the equal sign. There's no problem with that. I'm going to look at this expression on the right side of the equal sign, and it says x plus 40. So in order to isolate the variable, I need to do the inverse operation of plus 40. In that case, it is going to be minus 40. Now, once I do that, my balance is no longer happy and balanced, so therefore I need to subtract 40 from the other side of my equal sign. 120 minus 40 is going to be 80. That expression simplifies over there, and on the right-hand side, I get x. So I found the value of x to be 80. To check that, I'm going to see if that's true. So I'm going to rewrite my original equation, and now again I'm going to substitute the value that I found for x to be 80. And I'm going to see if this statement, that 120 equals 80 plus 40, to see if that's true. The left side is already simplified, and now I'm going to simplify the right side of the equation, and yes, both of my sides of my equation are true, it's balanced, and once again, we are very happy. Now we're going to change things up just a little bit. In this case, we have r minus 6 equals 24. The steps haven't changed. My goal is to isolate the variable. That r wants to be by itself. So it's going to kick the minus 6 out. And in order to do that, we use the inverse operation of minus, which is plus. So therefore, I'm going to add 6 to this side of the equation. What I do to one side, I have to do to the other side in order to keep it balanced. So I'm going to add 6 to this side of the equation. On the left side, we have r, because a minus 6 plus 6 gets us to 0, and 24 plus 6 is 30. To check to see if my value is true, I'm going to substitute back into my original equation my value for r. 30 minus 6, we're seeing if it does balance out to 24, and 30 minus 6, so my left-hand side of my equation is balanced, and my right-hand side of the equation, and they're equal, and once again, super, super happy. So to recap what we just learned, to solve one-step equation solving for addition and subtraction, we want to isolate the variable. In order to get the variable by itself, we need to perform the inverse operation to both sides of the equation. So if I have x plus 5 equals 20, I'm going to subtract 5 from both sides of the equation. If I have x minus 5 equals 20, I need to add 5 to both sides of the equation.